Yes, I will. At the end of class. All right, so we are going to be factoring the greatest common factor of polynomials. I'm going to show you some examples. I'm going to walk you through it, and then you guys are going to try some.
Pardon the interruption. Tyler Joppy, come to the main office. Tyler Joppy, come to the main office.
All right, so let's look at 8x minus 20x cubed plus 10x squared. All right, so what we're trying to do is, let me put it this way. In the past, we've been doing a lot of simplifying. We've been taking things that are complicated and we've been trying to dwindle it down into a smaller, more compact form. We're actually doing the opposite of that. So it seems counterproductive, what we're doing, but there is a purpose to this. In a couple weeks, we're going to learn how to solve quadratic equations. That's equations with variables that have exponents, specifically exponent of 2. And one of the couple ways I'm going to show you how to solve these, the fastest, most streamlined way is by factoring. So by factoring quadratics, we can solve them quickly. The other way is the quadratic formula, which takes a lot of detailed calculation. So factoring is faster. It's just there's a bigger learning curve. It's going to take us longer to learn how to factor, but it's a very important skill for solving quadratics. All right, that's why we're doing this. So it might not seem like what we're doing is very productive right now, but it will, I promise, in a few weeks. All right, so let's find the GCF. In order to factor out the GCF, we need to figure out what the GCF is. So the greatest common factor is the multiple that we are going to divide out of the terms. Now, it has to be the biggest. It's got to be in common with all of these terms, and it's got to be a multiple inside of those terms. So when we did the warm-up, how did we distribute that 2x squared y? We multiplied, right? Yes. So if we're doing this backwards, what should we do? Divide. So that's what we're going to do. We're going to figure out what the GCF is, and then we're going to divide it out. So we're going to do this one thing at a time. Let's just look at the coefficients. What is our GCF of the coefficients? 2. So here, is 1 a factor? Yes, 1's always going to be a factor of whatever you have in front of you, so we don't even count 1. Is 2 a factor? Yes. Is 3? 4? No, 4 is a factor for 2 of them, but not all 3, right? 5? 5's a factor for 2 of them, but not all 3. 6? All right, so we can see that 2 is the greatest common factor. Now, we could keep doing this factor thing all day. You want to stop once you get to 8. Once you get to the smallest number, you're not trying to find any more factors, okay? So 6, 7, and 8. 8 is a factor, but only for this one. All right, 2. Now, this is gonna go away for a second. It'll come right back up, but I wanted to show the video or something. So we have x cubed, and x squared. We have x cubed, and x squared. How many? So let's split these up. This is 1x, right? Yeah. It's a multiple of 1x. This is a multiple of 3x's. X times x times x is x cubed, right? And this is a multiple of 2x's. All right. So, if I'm factoring out, what can I divide all of these by? The biggest thing that goes into all of these. Just 1x. Yeah. So, can I divide this by x? What will I get? Just get 1, right? Can I divide this by x? What will I get? X squared, right? Because the 2x's will cancel. And this can be divided by x, right? So I can divide by x, yes? Can I divide by x squared? Well, I could on this one, because there's enough x's, right? And I can on this one because there's enough x's, but I can't on this one because there's only one x to do, right? So our GCF for the variable is just x in this case, okay? Yes?
So when you're like factoring or like just like.
So you don't want to do this. This is too much. This is more just why it works. So I'm going to show you what we're going to do in a second. But this is why we're only pulling out one x. Because there's only one x to be pulled out in the first term. Now if this was like this was x squared, x cubed, and x squared, then I could pull out an x squared. Because there's enough to pull from. Okay? Meaning I can't divide more than there is. I can't divide more than an x because there was only a single x. Alright, so this is what it looks like without doing all of that. My GCF here is 2x. Because this has an x, this has 3 x's, and this has 2 x's. I can only pull out 1. Just like I could only pull out a 2 from these 3 numbers because it was the greatest common factor. Okay, now, once you've decided what your GCF is, now we need to actually divide it out of all 3 terms equally. I want to divide 2x out of this, 2x out of this, and 2x out of this. Okay? So what is 8? So the first thing you're going to do is you're going to write the 2x out front of the parentheses. This is my GCF. It's what you're dividing out. All right, now, if I divide 2x out of 8x, what do I get?
4.
Just 4. Remember, I'm dividing by 2x. Dividing by 2x. And I'm dividing by 2x. And what do I get out of negative 20x cubed? Negative 10x squared. Good. Why did it go from x cubed to x squared? Because I canceled out one of those x's or I divided it out, right? And then this becomes 5x. This is it. This is your answer. This is fully factored. Now, before I answer your question, Amaka, let me ask a question real quick. How do I check my work? By multiplying this through here, and it should give me what I started with. Yeah. Amaka? Because I have an x squared here, and if I'm dividing out an x, then it's just x to the first power left over. It's like this, Amaka. If I had, so 10x squared is 10 times x, right? Right? If you divide out an x, you're just left with 1x, right? Yeah.
So like, if you do that like factoring,
So to check it, you just distribute it back through. Yeah, but we're not going to do that right now. Right? Okay, now, do you see how I did divide by 2x here? You're welcome to do that, but you don't need to. The only thing you need to see is this, the GCF, and then this. That's all we really need to see. All right, let's do another one. Negative 5w x cubed plus 10w x squared. All right. You'll see. I'll show you one next. All right, so let's do this one. What's our GCF of the coefficients? Okay, so it could be negative 5 or positive 5. Either one can be divided out. So let's just leave it positive for now. Quiet. Just leave it positive for now. Soon you'll have to decide whether to do negative or positive, but we're not there yet. So this is just 5. And how many W's can I pull out? Well, 1 from each one, right? 1 from the first term, 1 from the second term. So W. There's only one W here, and there's only one W here, right?
Yes.
All right, how many X's can I pull out? Two. So there's 3 of them here, right? And 2 of them here, so that means I gotta pull out a maximum of 2. Well, I could pull out 1 X, right? If I pulled out an X, how many would be left here? There'd be 2, and then how many would be left here? 1. That's called factoring, but not fully factoring. That's just pulling some of it out, not all of it. You want to factor out as much as you can. All right, so there's our GCF. We're going to write that out front of the parentheses, 5wx squared. And then in the parentheses, you're going to leave your, what's left after you divide, your quotient, basically. So what is negative 5 divided by 5? Negative 1. What is W divided by W? 1. It just goes away, right? They cancel. And what is X cubed divided by X to the second? X to the first, right? Yeah, this could be negative X or it could be negative 1X to the first, either way. I'll write it again the other way. All right, now, 10 divided by 5. W divided by W, they go away. X squared divided by X squared, they go away. That's your answer. You could write it like this, or if you wanted to leave off the ones, you could write it as 5wx squared negative x plus 2. It's fine. Either way. All right. Jada had a good question, and I did not show this to my other classes, so I'm going to show it to you because all right, example 3. Negative 9 PM cubed V plus M squared P squared Y minus 2 P to the 4th M cubed V. Yes, Savannah. No. Yes, sort of. What? Yeah. So can we factor out something from negative 9, 1, and negative 2? Just 1, right? Yeah. So yeah, the coefficient, we don't factor anything out from the coefficient. Okay. So the GCF is 1, but we don't have to write the 1. How many P's can I pull out? I got 1 here, 2 here, 4 here. Just 1 P. How many M's? 3, 3, 3. 3, 2, 3. 2. So M squared. How many V's? I've got 1 V, no V's, 1 V. No V's. It has to be in every single term. You can't pull it out of some terms. It's got to be common to every term, right? Because if I was to do this the other way, multiply it through, I should multiply it times every term, right? So V cannot be factored out. What about Y? No, it's only in one term. So the question Jada asked was, what if there's different variables in different terms? Well, if all 3 terms have that variable, you can factor it out. If they don't, then you've got to leave it. All right, so just PM squared. That's it. All right, let's write our PM squared times. All right, Lucas, what is left once you factor out PM squared from this term here? Negative 9 MV, correct. Good job, Lucas. All right, Joffrey, what's left after you factor out PM squared from the middle term? Very good. Now, does order matter? Could I do YP? You could. Order's not important. Huh? PY does look better, doesn't it? Yeah. Generally, you go by the order of the alphabet. All right, and then the last one, let's go with Esther.
We get -2 P3 M2 M1
Mm-hmm.
B.
Yep, that's it. Good job, guys. Yes. Number 2. Why isn't it -5? It could be. The sign isn't important. It is important later. For right now, just leave it positive. All right. Turn to page 285. You guys are going to do numbers 26 through 33. All right, before you do these, go to 185. I want to just discuss it with you real quick. 285. Sorry, 285. All right, the first 4 questions, okay, you're only finding the GCF, so you're only finding the greatest common factor. The second 4 questions, you're going to find the greatest common factor and then factor it out. Okay? Now, what happens if the only thing you can factor out is 1? So you would say that the GCF is 1, and there's a special name for that. It's called prime. P-R-I-M-E. Prime. Yeah. It's called prime. So there's going to be a couple of these with these problems. You'll see prime when only 1 can be factored out. Yes. No. Prime polynomials are polynomials that are not factored. Prime means it's you can write prime or you can write not factorable. Either way. In the computer, when you guys do your homework on this, I think they want you to put 1 as your answer. So if they ask you what's the GCF of this and the GCF